What's up, guys? Welcome back to the channel. Today we're going to continue talking about that 8th grade standard of rigid transformations. If you haven't already, go hit that subscribe button. That way you get those videos early. And don't forget to like if you like this video, and comment down below if you have some questions. I brought Tommy with me again. I hope you guys are cool with that. He just loves doing math. He's a little bit weird, like I am.
Oh yeah.
Please don't do that. You're ridiculous.
Nuh-uh, they think it's funny.
They don't think it's funny. They're literally not laughing.
Uh-huh.
Okay, whatever. You're wrong.
No, I am not.
Yes, you are.
No.
Yes.
No.
Yes.
No.
Stop arguing with me.
Huh.
Okay, we're going to do some math.
Okay. Jeez.
We're doing translations as well as reflections and rotations. And today we're going to look at this shape right here. Okay, so what's new is they call this shape VZYXW.
That's weird.
I know that's weird, but the reason they call it that is just so we can keep track of it. Okay, and our goal right now today is we're going to practice what happens to a shape. And we're going to also look at this word right here, and it's going to be super tricky. I'm going to show it to you here, because you're going to see it a bunch of times. It's right here. It's right here. Corresponding angles. See that right there? Can we say that?
No.
Try it. Go ahead.
Corresponding angles.
Exactly. You also have corresponding sides. Okay, so basically what that means, if we go back to our picture over here, it wants to know what corresponds or what goes with this side. And the reason we do this is this gives us your hairs in your face. Thanks. The reason we do this is we're trying to see if this shape right here, if we can tell whether it's reflected, if it's rotated, or if it's just a translation by looking at its corresponding sides. Okay, so check this out. So I'm going to start with, let's go a different color here so we can see. I'm going to start with this side, VZ. Okay, I'm also going to look at this entire shape over here, which is TPQRST.
Man, that's a mouthful.
That is a mouthful. So, TPQRST. TPQRS, okay? Now, if I'm looking at this shape, look closely. Okay, not that close. Oh my gosh. VZ, what would be the corresponding side with VZ?
I don't get it.
Okay, just think about it a second.
Okay, so...
Stop.
Ow, you poked in the eye.
You're fine. Look here, just to give you an example at the start. This side right here, TP, is the course.
You said TP.
Okay, stop. Okay, TP. Stop.
It's funny.
It's not. Just letters. Okay, so VZ and TP are corresponding sides, because if you notice, they're the same side, right? They just happen to be in different parts of it, but they're corresponding because it's the same part. So what would be the corresponding side to TS?
ZY?
Exactly, ZY, that part right there, because it's the one that goes with that same part on the shape.
Oh, I think I get it.
Yeah, so what would be the corresponding side that goes with SR?
XY.
Exactly, XY, because that, let's change the color so you can see it, because that would be the part that goes along with right here.
Oh, okay. So DQ goes with DW.
Exactly, DW. Good job, buddy. Starting to make sense?
Yeah. So what about corresponding angles?
Okay, corresponding angles, that's a good question. So if we look at a corresponding angle, it's the same idea. Okay, so if I look at angle V just by itself, this guy right here,
Yeah.
what would be the corresponding angle that goes with it?
Well, angle T.
Angle what?
T, right there.
Oh, P. Got it, you're right, that's the one that goes with it. And if I was looking at a different shape, like this shape right here, the EYCBA, or the EYCBA, what would it go with there?
Angle A.
Exactly, angle A, because that's the one that's part of that corresponding shape. What about the one over there?
H.
Exactly, those are all corresponding angles because they're the same angle.
Oh, I see. I think I
Alright, so let me ask you this, Tom. This shape right here, okay, and this shape right here, are those a translation, a rotation, or a reflection?
Let's see. So it didn't slide, so it's not a translation. It looks like it's kind of, like, flipped a little. Like, just turned. It's a turn.
So what would be turned?
Oh, a rotation.
Exactly, that's a rotation. And what about this one right here?
But did it slide? No, I don't. It looks like a mirror, so it's gotta be a reflection.
Exactly, so this one right here is the reflection. Okay, and then this guy right here,
Did it just slide?
it did, it just slid.
So, a translation.
Exactly, a translation. I hope you guys are starting to see these patterns too. This is what is going on with your transformations, but I have some more for you.
Yay! Whoa, what happened there?
Just relax.
Oh man, it looks like more corresponding angles and sides.
Exactly, it is. So first off, we have to identify the transformation. Okay, so we're looking at this shape right here, and we want to know how did it transform.
Oh man, that's tricky. I don't see it. Is it? It's kind of like a reflection, but it's not. And it's. Oh man, I don't know.
I have an idea, Tommy. Since we're looking at that shape right there.
Oh, you made it bigger.
Yeah, I did. So technology is one of those cool things where we can actually do some really cool things with technology. So I want to show you. So you're not sure what we did with that. So I'm going to separate that shape. Did I slide it?
No, because it looks different.
Okay. Is it a reflection, which means that it just is the exact opposite?
I don't think so.
Okay, so watch this cool thing that we can do. Okay, we can actually rotate this thing. Let's try this. Are they the same?
No.
Okay, let's try to rotate another one of these. Are they the same?
Oh, yeah.
Perfect. So that just shows me that this right here, because of how I did it, is a what?
Oh, rotation.
Exactly, a rotation. So, because it's a rotation, we identified that part. Here's the part we need to look at now. It wants to know what would be the corresponding side or angle that goes with this. So this little line above here, that means ST, that line right there, that means side. When you get this little guy right here, it means angle.
Oh, okay, that makes sense.
Okay, so ST, line ST goes with what? Keep in mind it's a rotation.
Okay, so I rotated it. Wait, can you go back to the other picture?
Sure, and just so you guys know, it's always really easy to just kind of draw the picture out, or you can do what I did and help you out. So ST goes with what?
XW.
Exactly, XW. So that's that guy right there. So there's XW.
Oh man, I think I get it.
Alright, what goes with UY?
Oh, UI goes with UV.
UV, exactly. So UV, this one is WX, and these are both lines, so they're all right. What about TU? TU.
UX.
Exactly, UX. Okay. Alright, now let's look at these sides. Okay, these angles on it. So angle S would go with what?
Oh man, angles are tricky.
Angles can be a little bit tricky, yeah.
Let's see. Can you go ahead?
Yeah, I'm going to go back to it. Okay, we're looking at angle S.
Angle W.
Yeah, angle W. Awesome. Good job. Beautiful. Alright, is it making sense?
Yeah, I think so.
Awesome. So with that in mind, Tommy, we are pretty much done. I think we can leave these for the rest for our friends to give it a shot and see if they know.
Oh man, that's a good idea.
Okay, so remember, if you guys have any questions, any topics you want to talk about, comment below, let us know.
Yeah, let us know.
Okay, Tommy, relax.
But I like teaching math. It's so much fun. Oh my goodness. Oh my goodness.
Okay, chill. Just relax. Ow, I bite my finger.
Don't stick it in my face.
Wow, attitude, turn it off. Punk me.
I will punk you if I want.
Oh, stop, knock it off. You're smaller than me, and I can throw you across the room.
Oh yeah, I forgot. I'm sorry. I'll be good. I'll be good.
You're fine, relax, dork. Alright, so that being said, if you guys have any questions, let us know, subscribe, don't forget to hit that like button. We appreciate you guys. Stay out of trouble.
Yeah, stay